What is binary? Interesting question. Binary is actually just two-way street. So there's only two possible options when you're dealing with binary. It's either 0 or 1, either on or off. So you may have known that already, but let's dive a little deeper into it. So why is this important to have binary? Or what is binary in the first place? So if it's a two-way street, there's only two possible options. It's either black or white. So if we imagine a tree, we can say, okay, should I go to the movies? Should movies, whatever. So you can either say, yes, I'll go, or no, I won't go. And there's no in between. You can't halfway go to the movies or 1/3 of the way go to the movies. Also, you can think of binary as a light switch. So the light switch can either be on or off. You can't have a light switch that's halfway on or 1/3 way on, unless it's a fader, but you know, that's different. So a normal light switch. So it's only two possible options in binary. So if you think about the normal context of binary, you may have heard that it's a number system. So how does a light switch and a two-way street and a decision relate to a number system? Well, a 0 or 1 as a digit is, there's only two possible options. So we can say in our number system that we have a base of 2. So if our base is 2, how do we represent numbers? Normally, we use base 10, and we have 10 different digits we can use to represent a number. So let's say we wanted to represent the number 145. You may have heard that each digit has a place, and each place has a name. We don't really think about this because it's so intuitive for us, but we can think of the 5 in 145 as being in the ones place. So that's 10 to the power of 0 is just 1. So we're working with base 10. So then the 4 you may think of as being in the tens place. Well, we can say that the tens place is 10 to the power of 1. And the 1 in 145 is in the 100s place. So that's 10 to the power of 2. 10 squared is 100, so that's the hundredths place. So if we use these place names that we've identified to create our number, we can say that 10 to the power 0 is 1, 10 to the power 1 is 10, and 10 times 10, or 10 squared, is 100. So we've got the ones place, the tens place, and the 100s place. So what we can do is take the value at each of these positions and multiply it by the value, its place value. So we can take 5 times 1, and that's 5. We can take 4 times 10, that's 40. And we can take 1 times 100, that's 100. And we can add them all up, and we get 145. We already knew what the number was because we wrote it in base 10, but what if we wrote it in base 2 in our binary system? We could say, I'm not going to write 145, we'll write a different number because it would take a lot of digits, but we'll say 1, 0, 1, 0, 1. That can be our binary number. And what we can do is, just like we did for base 10, we can identify a place for each of the digits. So if our base is 2, we can write a 2 here for each of these as the base, and we just raise each 2 to some power, and the powers go in increasing order from right to left. So 0, 1, 2, 3, 4. So this is really the ones place. Just like before in base 10, it's the ones place, but this is 2 to the power 1, 2's place. So that's different than in base 10, that was the tens place before. And what was the hundreds place before is now the 4's place, and the 8's place, and the 16's place. So then we do the same process we did before. We just take the value at that digit, multiply it by the value of the place, and we can add them all up to get the final number. So 1 times 1, that's 1, 0 times 2, that's 0, 1 times 4, that's 4, 0 times 8, that's 0, 1 times 16 is 16. And we just add them up. So 16 plus 4 is 20, plus 1 is 21. If you ever wanted to know, fun fact, what 21 is in binary, it's 10101. There you go. There you have it. That is what binary is. It is that simple, my friends. So, why is this important? Why do we have binary in the first place? Well, we can turn things on and off in a circuit. We can connect it to a battery, or we can disconnect it from a battery. We can turn the light switch off, or we can turn the light switch on. So it's also very easy to tell whether or not the light is on or off. We don't say a light is kind of on or kind of off, mostly. So it's very easy for us to say that a wire or a circuit or a light bulb or anything like that is either on or off. If we use base 10, like we do with our normal number system, to represent values on a wire, it would be very hard because we'd have to measure very precisely different intervals of voltages to get a specific number, whereas we can just say on or off for binary. So that's one reason why we use it, but beyond that is we can do math. Just like we do math with our normal numbers, we can add, subtract, multiply, divide our binary numbers as well. And that allows us to do awesome things like create simulations of bridges, use three-dimensional points to create models of three-dimensional things like people and skyscrapers and cars, and we can make very accurate and realistic looking representations of them using lists of three-dimensional numbers. But one thing that binary buys us that base 10 numbers do not is logic. So we can't say that 145 and 26 is yes or no. That doesn't really make sense. But we can say yes and yes equals yes, or yes and no equals no. So for instance, if you had, should I go to the movies? And I have two values that's based on, do I have enough money and are my friends going? So if you wanted to base going to the movies on those two things, you could say, do I have enough money to go to the movies? Yes. Are my friends going to the movies? Yes. Should I go to the movies? Yes. Or similarly, you could say, are my friends going to the movies? Yes. Plus, or and, do I have enough money to go? No. And that equals no. So you can do logical decisions with binary values that you can't do or don't usually do or intuitively do with normal base 10 numbers. So how does this relate to anybody in general, just, going about their day? You have, your apps and your phone and all this kind of thing. How does that relate to you in terms of binary? Well, if you want to represent a number, we've already said that 0 or 1 is a very good way to do that on a wire. And if you're going to use electronics, which I'm assuming you do, then you are using a system that's based on zeros and ones. So with those zeros and one numbers, we can create awesome 3D simulations and do math and all that cool stuff. But let's say you want to send a message to somebody on Facebook. There are billions of users on Facebook, and so in order to know who you're going to send the message to, you have to know what's their number, because we're sending them a specific message to a specific person. Just like you have to know a street address. So for every person on Facebook, there's a unique identifier, just like on any website. And in order to send that person a message, you must know that number. So similarly, let's say you want to create a filter in your email. You might want to filter out spam, and so you create a rule that says, anything that comes from my mom, filter it out. And that's a logical check. It says, does the from header contain my mom's email? Yes or no? Just like we did with the going to the movies example. And when you create that rule in your email, that literally boils down to a logical check of binary values to say, does this email match this other email? Yes or no? And if yes, then filter it to spam. If no, then keep it in my inbox. So those are two practical ways that binary and the number systems of binary must be used every single day by anybody. So that's pretty much it. That's what binary is, and that's why it's useful.